Section 12.1.3 is titled, Is it a function? And has a subtitle of Inverses or Trigonometric Functions. You will need a couple things today. You're obviously going to need your unit circle, some tracing paper, and then you're going to want to look at page 12 first before you complete this section. And so the objective is that by the end of this lesson, you'll be able to graph the inverses of trigonometric functions and recognize the restricted domains that allow the inverses to be functions. So for question number 31, you're going to fill in the table for y equals the sine of x using your unit circle. Then you're going to graph the points on the graph below. So filling in the table from your unit circle, at 0, you'll have a point at 0. At pi over 4, you'll have a point at rad 2 over 2. At pi over 2, you'll have 1, and then keep filling it in. The dashed line should be provided for you, and then you're going to fill in the sine wave. So the line of y equals x is drawn on the graph. You're going to use the tracing paper to reflect the graph of y equals sine over the line of y equals x. Recall the inverse functions reflect over the line y equals x. So this is the start of the inverse sine function. And then you're going to draw in the inverse using a different color. So when I line up and when I trace over with my tracing paper, then I'm going to reflect over on the dash line. You're going to see that the inverse is going to look like this. So I don't know if you can see the one under it, but that's what it's going to look like. All right. Turn over to page 10. Up at the top of page 10, it's going to pose some questions to you. It says, consider the graph of y equals sine of x and the inverse function y equals sine inverse of x. Write the domain and the range of the y equals sine of x below. So the domain for the sine of x is going to be all real numbers, and the range is going to be from -1 to +1. For part 2, they want you to write the domain and range of sine inverse. So you're going to reverse what you had for the sine of x. So the domain is going to be from -1 to 1, and the range is going to be all real numbers. Recall that for a graph to be a function, it must pass the vertical line test. So is the graph of sine of x a function? That would be yes. And is the graph of the inverse sine of a function? And that is going to be no. So they want you to discuss it with your team, the restrictions you would need to make on the domain of the original function y equals sine of x so that its inverse is also a function. Write your prediction below. So it should go from negative pi over 2 to pi over 2, which would be a complete cycle. Question 32 says, now graph the inverse sine of x on Desmos. How is the result different from the graph that you made on the previous page? All right, so here's what it looks like in Desmos. I did the sine of x in pink and the inverse sine in yellow. So how do you get it? So you're going to go to Desmos, you're going to go to the little keyboard, click on functions, and then you're going to see your inverse trig functions. And so that's how you'll type that in, and that's what your graph will look like. Okay, so the question is, for part A, how is the result different from the graph that you made on the previous page? So to me, it looks short. It does not go to negative infinity or positive infinity. And so the domain is going to be from -1 to +1, and the range is going to be from negative pi over 2 to pi over 2. Does it make sense in terms of your answer? in problem 31. So the answer would be yes. It sort of makes sense. It's the inverse or the switch of the function. For part C, they want us to highlight the portion of your graph that represents the inverse function. Also highlight the portion of the unit circle below that shows the same restriction required to make its inverse a function. All right, up at the top of page 11 is question 33, which says, consider the equation of the sine of x where it is equal to negative square root of 3 over 2. How many solutions does the equation have? So it is going to have infinitely many solutions because they're going to repeat every cycle. So for part B, they want you to look at your unit circle and solve for when the equation of sine of x is going to be equal to the negative rad 3 over 2. So on the unit circle, you're going to see it in two spots. You're going to see it at 4/3 pi and at 5/3 pi, which makes it seem like it's just 2, but it's going to be multiples of each of those, how many ever times you're going to keep going around that unit circle. So we write it as 4/3 pi plus 2 pi times n, how many ever times, and 5/3 pi plus 2 pi times n, how many ever times you're going to go around and around that circle. So for part C, it says, which solutions do you predict your calculator will give? And so if you type in the inverse sine, let me get there. Oh, wrong one. Inverse sine of negative square root of 3 over 2. It's going to give you approximately negative 1.047, which is the same as if you were to type in negative pi over 3. You're going to get that same answer. So it says, use your calculator. Were you correct? Why do you think your calculator gives this result? Because it's calculating it in radians, not degrees. If you're in degree mode, it's going to give you an angle measure and tell you where it's at, to look at how many degrees you would need to look at on your unit circle as well. All right. So now we're down at the inverse cosine of x. So the graph of the inverse cosine of x is shown to the left along with the restrictions on the unit circle. Notice the restriction for the y equals the inverse cosine of x on the unit circle is now between 0 and pi. So with your teams of 4, you're going to finish question 35. It says, for each of the following equations, list all the solutions without using a calculator. Use your unit circle or a graph to check your answer. Then predict the solution that your calculator will give and use your calculator to check your prediction. So for part A, I did for you. Parts B and C, you're going to do in your groups. So for part A, I isolated the cosine of x by itself by adding 1 to both sides and then dividing by 2. Then I looked at my unit circle to see where the cosine was 1/2. There were 2 spots. One was at pi over 3, which gives me pi over 3 plus any multiple of that. And the other one was at 5 pi over 3, which gives me 5 pi over 3 plus any multiple of that. So finish B and C with your teammates, and then you can go ahead and work on the review preview.